Okay, so in this video, we're going to go ahead and continue where we left off for pre-calculus 9 weeks review for our 9 weeks test. This is number 25, I believe, on your paper. So we're going to go ahead and try to solve it. It says given the function f of x is equal to 4x minus 5 squared plus 2, and f of x is also equal to this, so you have that f of x equals g of h of x and all of this, okay? Which functions below could represent g of x and h of x? Prove it using composition. So we're going to kind of try a few different things, okay? We're going to try, first of all, let's say it's a different color. So let's let g of x, okay, because that's the outside function. So g of x is the outside function. Let's let that equal to this first one right here. Okay, so x squared plus 2. Okay, we're going to go ahead and see if we can plug something into that to give us this 4x minus 5 squared plus 2. Okay, so let's let h of x equal, let me see, we'll try the next one, the one right next to it. So 4x minus 5. Okay, and what I'm going to do is I'm going to do the composition. So I'm going to do g of h of x, so g of h of x, and I'm going to see if I get this answer right here. So this is the goal. Okay, we're trying to get this. Okay, so g of h of x would be starting with a parentheses squared, so this right here, and then plus 2. Okay, now inside that parentheses, I'm going to go ahead and put h of x. I'm going to put all this in there. So 4x minus 5. Okay, and if I look, this is exactly what I wanted. So this is one possibility. So g of x could be x squared plus 2, okay? And h of x could be 4x minus 5. So this is one possible combination. I'm putting a comma because there could be some other ones. So I'm going to go ahead and kind of tie these together like this line. So these two together work. They work out, okay? Now we're going to try another combination because we have other functions. So we're going to try letting g of x equal to, I guess, the next one. So let's do 4x minus 5, okay? And let's let h of x equal x plus 2. So I'm just going down the line, okay? And I'm not going to do all the combinations. I'm going to leave that to you to do. I just wanted to show you a few of them just so you can kind of see how this works, okay? We kind of have to try different combinations and see what works and what doesn't, okay? So g of h of x in this case, we would have g parentheses h of x on the inside. Oh, one color. Okay, so this would be equal to all this. So the square root, I'm going to put my 4 in there. And instead of x, I'm going to go ahead and put a parenthesis. So parentheses and then minus 5. Okay, and inside that parentheses, I'm going to put all this. So x plus 2. Okay, now this one looks like it requires a lot of work. So let's see, we're going to have the square root of, we're going to distribute, that's going to be 4x. 4 times 2 is 8, so plus 8. Bring down the 5, so I'm just working out this part inside. And that's going to give me the square root of 4x, 8 minus, so right here, 8 minus 5 is plus 3. So this does not equal this. So this one is a no. Okay, this one is not going to work. Let's try one more just because I have the room. Again, you're going to have to try multiple combinations, guys, okay? I believe there's at least 2, maybe even 3 that work, so you need to try them out. So let's try, let's see. We're going to try g of x equal to this one. So 4x minus 5 squared, okay? And let's let h of x, I use a different color for that. Let's let h of x equal to x plus 2. Let's make it simple. So I'm looking at these two right here, okay? So we're going to do the same thing. So g parentheses, and then h of x on the inside. And that's going to start off with all this. So parentheses 4, okay? And that's going to be, again, another parentheses, minus 5 square, okay? And inside that parentheses, we're going to plug in this x plus 2. So that's going to give us, distribute 4x plus 8, and again, minus 5 square. So we end up with 4x plus 3 square, which again, this one is not equal to this, so this one's not going to work either, okay? Now, I mentioned there is another combination that's going to work. So for you, what you need to do, you need to find one more combination that works, okay? So you can try something else. You can try maybe let this one equal to g of x and let this one equal to h of x. I don't know, something like that, okay? But you need to try that part. So I'm going to go ahead and leave that for you. Oh, whoops, I erased everything by accident. And you let me know in class if you have any questions, okay? Go ahead and move on to the next problem. So this one is, I believe, towards the end of your packet. It's on the second page in the middle. And it's a little tricky, so I wanted to go over a few of them, okay? So this one is talking about if g of x is equal to all this. So g of x is equal to, let me get my pen back. G of x is equal to, pen, there we go, is equal to all this, okay? Then you have to find specific values for x. So in the first one, we have g of 0. Now the problem is that this graph is in terms of f of x, not g of x. So we're going to kind of have to work backwards, okay? Remember that this right here, this f of x, this is just y. Okay, that's equal to y. So in other words, I need to find the y value for when x is equal to 0, if that makes any sense. Okay, so right here, okay, when x equals 0, okay, well, that's right here in the middle, y is also equal to 0. Okay, so what I'm going to do is I'm going to plug this number into here. So it's going to be 2 times, well, now f of x is 0. Okay, so I'm taking, I can color code it if you want. So y is equal to 0. I'm taking this right here and I'm plugging in what it's equal to. So I guess I can do the arrow like that. Okay, so this is the same as that. So 2 times 0 plus 1. Well, 2 times 0 is 0 plus 1 is equal to 1. So the first one is just 1. Okay, let's try another one. So let's say now we're looking for when g of e is equal to 1. Okay, so when x is equal to 1, I'm sorry, when x is equal to 1, when x is equal to 1, y is equal to negative 1. So y is equal to negative 1. Okay, so that means I'm going to have 2 times negative 1, okay, and then plus 1. So that's going to be 2 times negative 1 is negative 2. So negative 2 plus 1 is equal to negative 1. Okay, so this second one is also equal to -1. So far it turns out like a lot of these are pretty similar because this is pretty linear even though it's negative. Okay, let's look at another one. So this is when x is equal to 2. Okay, so when x is equal to 2, that's right here. This one is -2. So y equals -2. I'm going to do the same thing. I'm going to go ahead and plug that in. So 2 times something plus 1. And we want -2. So -2 goes in here. Okay. So 2 times -2 is -4 plus 1 plus is equal to 3, -3. Okay. So -4 plus 1 is equal to -3. So that's pretty much it. We can do one more if you'd like. I'll skip down to this last one. So how about number 8, or in your paper it's number 33, okay? So when x is equal to -4, y is equal to, let's see, so -4 is right here, so y is going to be equal to 0, okay? So it's kind of like the first one. So these two are similar. So we have 2, I'm going to do it all in green if that's okay. 2 times 0 plus 1 is equal to, well, 0 plus 1, which is equal to 1. Okay, and that's how you do this part. You're finding the value of y. So you find the y value when x equals the number given. Okay, and then you just plug it in. That's about it. Okay, let's move on. We're almost done. Yes, we're getting there. We're at the end. Okay, so this last part is inverse. At least I'm not last part. Second to last part. These 4 problems are inverse. For inverse, we have a few steps. So first, you want to change f of x into y. Okay, so in this case, it'll be y equals 2x plus 1. Okay, step number 2, and you have this in your notes, by the way. Step number 2 is to switch x and y. So now we have x equals 2y plus 1. Okay, and the last step, let's use a darker color, let's use blue. The last step, number 3, is, well, almost last step, is to solve for y. Okay, so we're going to go ahead and do that. We will subtract 1, subtract 1. That's going to be x minus 1 is equal to 2y. Divide everything by 2. So, and I'm out of room here, so I'm going to jump up here. So it's going to be y equals x over 2 minus 1 over 2. That's pretty much it. You could change this to if inverse, so you can do one more step there. So number 4, change y into f negative 1x. And this is just the inverse notation. Okay, so that would be f of negative 1x is equal to x over 2 minus 1 over 2. Okay, and that's it. So I'm going to go ahead and do these next ones pretty quickly. I have to write a little bit smaller because I ran out of room. So this first step would be y equals the square root of x minus 6. Okay, then I'm going to switch x and y. So x equals the square root of y minus 6. Okay, then I'm going to go ahead and solve. So to solve for this one, I would have to square both sides. So square, square, that gives me x squared is equal to, that's gone, so y minus 6, okay? And then I'm going to add 6, so plus 6 plus 6, and that's going to give me x squared plus 6 is equal to y, and that's pretty much it. We just need to write the answer officially. So we can do that with the inverse notation. So f of negative 1x is equal to x squared plus 6. And if you notice, everything is just opposite. So here, instead of a minus, we have a plus. Instead of a square root, we have a square. The 6 used to be inside, and now it's outside. So everything is just opposite of what it originally was, because that is what inverse does. It switches everything around. Okay. All right. So I'm going to go ahead and do two more actually, because there's two more. Let's look at this one. So this one's kind of tricky because you have this fraction thing going on. So let's get through this one. So this is going to be y equals 1 over 3x plus 2. Okay, then we're going to switch x and y. So we're going to switch x and y. So it's going to be x equals 1 over 3y plus 2. Now this looks kind of weird. So what I'm going to do is I'm going to fix it because it just looks really weird to me. So I'm going to put this over 1 and I'm going to flip everything. So right here, I'm going to flip everything because I want the y on top. So if I flip everything, this gets flipped. So now it's 1 over x equals 3y plus 2. Okay? And we're almost done. We're going to go ahead and move the 2 now. And this one is kind of a long problem. Sorry about that. So we're going to subtract 2 from both sides. Okay, and I'm going to jump right here because I'm out of room here. So we're going to have 1 over x minus 2 is equal to 3y. Okay, gets a little even more trickier because now we have to divide by 3. And I believe the one of your exam is not this difficult, but it's still good to know. So we're going to divide everything by 3. Okay, so what that does is it gets rid of the 3 over here. And this one's just going to be equal to 1 over 3x because it's on the bottom, so therefore it'll stay on the bottom, minus 2/3 is equal to y. And that's about it. We just change the notation. So f of inverse of x is equal to 1 over 3x minus 2/3. Okay, and that's for this problem right here. Okay. All right, one more of these, and then we're going to do the last 3. So we have find the inverse for this problem. So now we're looking at this problem. This one's kind of weird because you have this is equal to y, so y equals 9, but there is no x value. So since there is no x, we cannot find inverse algebraically. Okay, so this is going to be an impossible one. Okay, so just don't forget that. Okay, if it's just a number, it's just a constant, therefore there's no x value that goes with it. Okay, all right, so last problems. Looks like we're out of room too. So let's go ahead and look at this one. Number 43 is just more of a note that I wanted to point out. It says the functions f of x equals this and g of x equals this are equivalent functions. Give another example of equivalent functions. Equivalent means they are the same. Okay, so you just need to graph on a calculator and compare. Okay, that's it. So graph it. Get your Inspire, graph it, and make sure that these two are the same. If they're not the same, then you'll see two different graphs. If they're the same, then what's going to happen is you're going to have you'll have something like that, I believe. Okay, so let's say this one is f of x, and then g of x will be right on top of it. So you'll have g of x right on top of it because they're equal, okay? So I just want you to understand that, what this word means, equivalence. Okay, one more. Actually, no, two more, I'm sorry. Two more. Let's go ahead and look at the second to last problem. So this is solve for the variable. I want you to rewrite this. 39 is equal to 3 square root of x. So 1/2 is the same as a square root. Don't forget that, okay? And we're just going to solve for x. This is more of a review problem because I don't know if you guys remember how to do this or not. So I'm just showing you just in case. So we divide both sides by 3 first, okay? 39 divided by 3 is 13, okay? Which leaves us with 13 is equal to the square root of x. Now to cancel a square root, we square both sides. That gets rid of the square root. 13 squared is the same as 13 times 13. And 13 times 13, if you use a calculator or, the long way, is going to be 169. And that's it. Done with that one. Okay. Last problem. We're finally there. It says, given the function f of x is equal to 4x plus 2, if f of 3a is equal to 75, what is the value of a? All right, so in this one, you kind of have to work a little bit backwards, okay? Remember that this number is y, which is also f of x. Okay, and I'm sorry it's a little crowded here. So what I'm going to do is I'm going to say, well, this is going to be equal to 75 because f of x is your y, okay? So it's going to look like this. 75 equals 4x plus 2. But it tells us that this is only true when f of x is, when f of x is 3a. So I need to plug in 3a into here, into the x. So now I'm going to have 75 is equal to 4 times 3a plus 2. And this is what you're going to solve. Okay? So 4 times 3 is going to be 12a. Bring everything else down. Use a brighter color. So we have 75 is equal to 12a plus 2. Okay, so I'm just going to solve for a. So subtract 2 from both sides. It's going to be 73, okay, is equal to 12a. From there, we divide by 12. Okay, and I believe the one in your, I think the one in your test is a perfect number, but if not, you have a calculator, you can just plug it in. So 73 divided by 12 is going to be approximately 6.08. That's it. So A is equal to 6.08. That's it for this review, guys. If you have any other questions, again, ask me during class. If it happens to be a time when I'm not there, you can also email me and let me know, and I'll get back to you as soon as possible, okay? Good luck on finishing this review, and good luck on your exam.